So this is section 3.7, and it's modeling linear data. And let's take a look at example 2. Okay, so example 2, this could be a nice one because it's a line that can model linear data that we use to model gas mileage. Okay, so we're determining gas mileage. They're giving us this table for an SUV, and it's X gallons of gasoline. So X is the gallons, and Y would be your actual number of miles that you actually drive. So they want you to plot the data on an XY plane. So that's what they did here. They plotted the actual points here, and then they sketched a line that models the data. So they actually drew a line right through the data. This was able to go through all the data points this time. Alright, and then find the equation of the line that interprets the slope. So that's what they did. They picked 2 points. They picked 2, 30 and 8, 120, and they were able to calculate slope to be 15. And then they used the equation of point slope form to come up with their final equation, which was y equal to 15x. Okay, and then in the end, you're supposed to be able to take your equation and predict what the actual how far the car could actually travel at 11 gallons. And so here they're doing the 15 times 11, so they can go 165 miles. So let's do the same thing with problem number 51. So let's go to that page, which is on page 244. Okay. So here's 51. It's gas mileage again. So the table shows the gas mileage. So we'll make sure we write that down, and we're going to plot it. So I'm plotting this table on a calculator, which I'll show you how to do later, but you should do this on regular paper. Go ahead and graph this on regular paper. So plot the points. So here is my graph right here. Okay, I actually set my window from 0 to 15, counting by ones for my x, and then I did 50 all the way up to 250 and counted by tens. So that's why my graph looks like this. Okay, and so I was able to plot all my points and draw a line through all the points. So this tells me this is an exact graph for me. I'm going through all the points. So let's go and calculate the slope. Alright, so let's go back to my paper. Okay, I'm going to pick the 2 endpoints, okay, for this one, for number 51. So one of the points I'm picking is 3, 60, and then the other one is 12, 240. Okay. So this will be my x1, y1, x2, and y2. So my slope is going to be 240 minus 60, and then 12 minus 3. So 240 minus 60 is 180, and then this gives me 9. So I end up with a slope of 20. Okay, so that means I'm getting 20 miles to 1 gallon. That's what it's basically saying. So now I can put that into my point slope form. So y minus, I think I'll use the first point, which is 60, equal to 20 times x minus 3. So I'll go ahead and distribute. So that's 20x, and then minus 60. Okay, and so then I'll add 60 to both sides. Oh, my numbers drop out. So y equal to 20x is going to be my equation. So now looking at the book again, here's the book. Okay, it says calculate the slope, which I found to be 20 over 1. Find the equation. I did that. And so how far could this car travel on 7 gallons of gas? Okay, so I go back to my work and I'll put in 7. So y equal to 20 times 7 gallons. Okay, and notice here I'm going to put in the units, 20 miles per 1 gallon, and then the 7 is going to be gallons over 1. Notice my units cancel, and that ends up with miles. So now when I take 7 times 20, I get 140 miles. Here's my Y. So that's how far the car can go on 7 gallons of gas. So this is just another type of problem where you're given a data and you're supposed to come up with the slope as well as the mileage, the equation, 20 miles per gallon times the X number of gallons, and then you use that equation to do a prediction on your particular setup. Okay, and that's basically how we do these modeling with linear equations.